Tonight on our controls instruction, presentation, whatever you want to call it, we're going to do intro to pneumatics. So we're going to be looking at the pneumatic system of the robot. The pneumatic system is how we're able to use the energy that we gain from compressing air, and so we can use it to create motion on the robot. So that's the main idea of what happens. But it's a whole separate sort of system from the electrical system. There's parts of it that are connected so that we can use the electrical system to control it. But all of the we do have to have a system that allows us to store the air, to run the air to the various components that actually need to use it. We have to be able to monitor it to make sure it's all within the correct specifications, and we have to have it make sure that it's all stored safely. Because if you were to store too high of pressures, things might fail in ways that we're not expecting, potentially causing harm to people if they shatter and send pieces flying or anything like that. So we want to make sure everything is safe. So all of the systems are all in place, and a lot of the components we're going to talk about tonight are all there to allow us to use the system safely and effectively to work and to meet the functions of our robot. So this is the kind of basic model of what happens on the robot for the pneumatic system. We're going to go through each of these little components and talk about what they do. Excuse the kind of line drawing Google Slides art, but this is the best way I could get to show how everything's connected quickly. So this is what it kind of looks like in real life. So this is the vast majority of what's on here. So all of this bottom half of this image is basically all tucked in here. So it's a lot harder to figure out exactly where everything is connected in here because it's all behind things, and there's a lot of different tubes. So these are all for the different functions on the robot. These are all connecting different ones of them, and so because of that, this looks pretty complicated. But as we break everything down, it should make more sense. And so we'll come back at the end and we can kind of point out where everything is and how it relates to this sort of easier model of it. Okay, so there are a couple concepts to go over before we dive into what each of the parts are. One of those is what we talk about when we're talking about pressure. So atmosphere right now, which all of us are standing in, breathing, we're sucking air in, we're sucking air out. There is air pressure around us at all the time. If there wasn't, we would be in a vacuum and we'd stop breathing, and that'd be bad. So whenever something on our system is like exhausted, anytime we just say it's no longer connected and confined to our system, we just release that pressure into the rest of the atmosphere. And that's kind of what happens when we exhaust anything. It's just going to atmosphere. The atmosphere does have a actual pressure, but we are not concerned with it because since everything is always acting inside of, we're doing all of this on Earth, we're not doing this in outer space or underwater or anything else, we can always assume that pressure is basically zero. So when we're talking about pressures, if we say a number, it's always above what our normal atmosphere pressure is. And that's normally what's called gauge pressure. So when our gauges read zero, we'll talk about what the gauges are in a second. Whenever they're reading zero, they just mean it's what normal atmosphere, everyday, walking around in air pressure is at. And then when we start storing pressure and we build up more pressure, it's whatever the normal pressure is plus whatever we're actually reading on our gauges. So what is air pressure exactly? Maybe I should flip these slides in the future. I don't know. The way we measure air pressure is in PSI, or pounds per square inch. As our compressor, which we'll talk about exactly what it does in a second, as it runs, it's adding more and more air to our system. So we're literally putting more and more air into the same amount of space. And because of that, the air is all trying to basically escape. And that energy or force that it's using to kind of push apart all the little tubes and every place where in the storage tanks and every place that it's stored, it's trying to expand out and get back to normal atmospheric pressure. And since it can't, because we're storing it in that space and we're shoving more and more air in, it builds and builds and builds, and we gain more and more pressure. And we measure how much pressure that is in PSI, or pounds per square inch. In FRC, we are limited to storing air at 120 psi. So that's where we have it, or roughly, it's an approximate. And so that's where our compressor will stop. We'll turn off the compressor once we've reached about that number. And then that's how much air we're allowed to store. So we can add more storage tanks. So we add more storage volume. We'll talk about storage tanks in a little bit. Then we can store more air, but it can never be stored above 120 psi. So that's just one of the numbers that's useful to know. It doesn't dramatically change anything. Just know that we store it at a certain. We are limited on how much air at what pressure we're allowed to store air. Yeah, so because air is always trying to expand, it does fill any volume that it's trying to expand into. So as we shove more air in, it's all going to disperse throughout the whole system. So it's relatively equal pressure throughout the whole system. So that means we can track how much air is in our system by just monitoring how much the pressure is at any one time. So we don't have to try to figure out like the weight of the air or anything else. We can just look at pressure and we can know how much air is in our system. Okay, so one of the first parts of the system, and one of the thing that if we didn't have the whole system wouldn't work, is the actual compressor. So this is just a graphic representation of it clearly. And it will, over here on the right, you can kind of see what the real one looks like. And so this compresses air and feeds it into our system. So basically, it's like a pump, and it's taking air from outside of the robot, just outside in the atmosphere, and it's shoving it into the hose that ends up being connected right here on the end. So it's just shoving more and more air in. This little part right here, right at the end, is actually what's called a check valve. And what it does is it doesn't allow any air to come back through the compressor. So no matter what happens, air can only go out of the compressor. It can never come back in. So that allows it to just shove more and more and more air and feed more and more air into the system. And then it just builds and builds and builds pressure. So that's the whole thing that the pneumatic system relies on, is that buildup of pressure. And then when we go and direct it into different places, we can use that pressure to do stuff. The compressor basically just has a motor inside. So this part right here is a motor. And back here, it just has a pump. And it's just pumping air into this outlet right here and into our system. We are only allowed to have one compressor. So you're not allowed to have multiple compressors. There are limitations on exactly what specifications of compressors we're allowed to use. So we're not allowed to have compressors that are too big or too fast at compressing air, basically. Like they have to have a certain rate of how fast they can compress air. We're not going to go into it here, but I will send a link out to this presentation if you want to learn exactly how a compressor works. There's a video on that. We don't open or maintain these or modify them. We're not building our own compressors. This is just a part that we buy. So it's not super important to know exactly how it works. You just have to know what it does. Okay, tubing is the next and very critical piece of how our pneumatic system works. So tubing is how we're able to connect all of our components together. This provides the path for the air to flow from every single component. We have two sizes of tube that we use on the robot. We have this size right here called 1/4 inch, and we have the smaller size called either 5/32 inch or 4 millimeters. They're basically interchangeable. The sizes end up working out where they're pretty close to identical. So even if some place sells it as 5/32 or some place sells it as 4 millimeter, they're pretty much all made as the exact same tube when they actually make it at the factory because of how close the sizes are. So it doesn't really matter which one you buy. They're all basically the same. Which ends up being convenient because then that means we can use parts made in America that use 5/32, or we can use parts made internationally that are more commonly using 4 millimeter. So a lot of times they'll be cheaper sometimes if we can buy international parts. So it just sort of depends. But this does work out in our favor that they're the same both in standard measurement system and in metric measurement system. That does not work for the 1/4 inch ones. There's another size, 6 millimeter, that is close to the same size but not quite right. So if you end up trying to interchange them, you'll end up with air leaks, and air leaks are bad, and we'll talk more about that as we go through. But basically, if you have an air leak, you lose that pressure that you've been storing because more of that pressure can just be vented to the outside, and eventually over time you won't have any more pressure if you have a leak in your system. The tubing is relatively cheap, so we just figure out how long we need and we cut it. We do want to try to make sure that when we cut it, we have really square ends. If you end up having like an angled cut on the tube, it can cause air leaks too because it doesn't like fit in the connectors very well. You don't want to have these like bent too hard to where they'll kink and they'll like fold over, so where they don't allow air to flow through or not very much air to flow through. That also wouldn't be good. So we do want to take care of the air hoses, make sure they're not damaged anyway, make sure they're not leaking air. But they're pretty robust. Most of the time we just zip tie them up against something and keep them out of the way. Make sure nothing like spinning is going to grab them and tangle them or anything like that. Okay, so from the compressor we have this hose right here that's going to go to a few different spots. And one of the things it connects to is one of our gauges. So we have two gauges. We have one here that's connected with this red hose, and we have one here which is connecting with the green hose. And gauges are how we actually measure the pressure at any point in our system. So this is how we're able to tell is the how much air is stored in our system, because if we have this volume and we know how much volume is there, if we can read the pressure, then we know actually how much air is in there. And pressure is really important because that also changes. We'll talk about that, but that changes how much force the pneumatic cylinders, that when we actually ask them to move, how much force they move with is based on that pressure. The dial shows pressure in PSI and in bar. We do not use bar very often. If you're ever asked to read how much pressure is in the robot and you tell someone it's 5 bar or 6 bar or whatever, they're not going to really know what you're talking about. We largely use PSI for everything, so that's the smaller inner dial on these gauges, which is kind of annoying because it's sometimes hard to see exactly like which tick it's at or which mark it is. Most of the time, as long as you're getting close, you're okay. You don't want to get eye level with it, looking straight on, so you can see where the gauge is. Where the needle's actually pointing, to see if it's like actually pointing at 100 or is it pointing at like 80, so we can get at least a decent approximate value of how much air is stored in our system at that time. These are the standard gauges we use. They're really small and light. There are a lot of variety of air gauges that you can use. Other teams will use different ones. Most of them are bigger and heavier. We want to try to use as lightweight of components as possible so that we're not using up the weight restrictions of our robot. So we have a max weight on the robot every year. So if we can use very light components instead of a slightly heavier component, that means more of our weight can go to something else that can probably help us score more points or build a better robot. If there's two equivalent things, they're not going to affect how the robot operates necessarily. We're going to almost always try to use the lighter one, especially if it's also convenient, relatively inexpensive, that sort of thing. Okay. In this diagram, between our two gauges, we have what's called our regulator. The regulator is an extremely important part of our pneumatic system, and it's one of the things that allows us to use pneumatics safely. So the regulator, the regulator limits the pressure passing through it. So it basically allows you to have two different pressures on each side of the regulator. Air on the input side of the regulator has to have a higher pressure, and it doesn't necessarily matter how high it is, because what the regulator is going to do is limit how much air can be on the output side of the regulator. So when you turn the screw at the top, so this little screw up at the top here, you can lower the allowed pressure on the output side. So as we tighten this screw, the pressure that is on the output side goes down, and as we open the screw, the pressure gets higher and higher. I believe that is true. On occasion, I get those backwards, but I'm pretty sure I said it right this time. If for some reason the pressure on the output side is too large, it will vent, which means it'll allow pressure to escape from this output side to where it gets back down to wherever it was set in. So we use those gauges to be able to set this. So we have a gauge on both sides, and as we turn this screw, we can see how it adjusts the output side of the regulator, and we can see what the number changes to, and we can see what pressure it's allowing on that output side. Um, there are tiny little arrows here that are sometimes hard to see. That's why I have this super zoomed in. There's a little arrow pointing to the right, and so that means the right side here is our output side, and the left side is our input side. It's relatively common to install these backwards, right? The diagram does not give you much. There's not like color coding or anything super useful. We actually, now that I think about it, we should probably color code ours. We might do that to make it super obvious which side is input and output. But they do have little arrows. If you get in and look at it, you can tell. So the output side is always the side that's going towards the stuff on our robot that actually needs to be moving. We'll talk about exactly what these are in a second. And then the input side is the side that has the compressor on it and all of that stuff. So the important bit of this is that for safety reasons, we're allowed to store air at a higher pressure than we're allowed to actually use air. So the usable air is what causes these cylinders to move back and forth and like get actual motion. And so we need the regulator to limit the amount of air pressure we have on our usable side, but allow us to store a larger amount of air on our storage side. So this red side is going to be high pressure, and this green side is going to be a lower pressure that we're actually able to use. In FRC, the rules are that this can be 120 psi, like we talked about earlier, on the left side, and the right side can be at most 60 psi, so half of what we're allowed to store. Okay, so talking about storage a little bit more. So we have air tanks or storage tanks, whichever you want to call them. And so this is where we actually, they're often other times called air accumulators, because that's what they do. This is where we accumulate all the air. So as the compressor is pumping air into the whole system, these just allow us to have a large volume of stored air that we can then be ready to use when we need to put air into one of the cylinders that we make that does actually all movement and allows us to use all this air pressure we're storing. So these are like the reserves and they're ready to go, so we can very quickly use the energy from the stored air to do the motion of our robot. So we'll have multiple of these on the robot. There's no moving parts. They're relatively simple devices. They're just literally a big hollow empty cylinder. They don't look like anything special. You can, if one of them's off the robot, you can like look in. They're just a big empty cylinder of plastic. We almost always use these white air tanks because it fits our brand better. Our colors are purple and white. But a lot of teams will use these black ones. There's some teams will use metal tanks. If there's ever a game where we need just like a ton of air volume for some reason, where like every mechanism on our robot is pneumatic for some reason, we're not using as many motors, and we just have like a lot of pneumatic usage, we do own like a giant metal air tank. It's very big, several gallons large, but we only use that if we need like a lot of air stored for some reason. Most of the other time, we're going to use multiple of these white air tanks, so we'll use 3 to 6 of them on most robots, kind of depending on how much space and weight and how much air we're actually using for any of our functions. And so these are all just connected together. You can put fittings into here that allow you to connect the hose to them. And then as long as all of the hoses are connected together, air will find its way into the tank, and then you can store it there waiting for use. Okay, a couple more of our safety features in the way that the robot works is one of them, and a very important part of this to keep everyone safe, is our pressure relief valve. So that's this device here. This device is always mounted basically directly onto the output of the compressor. And so this is here to make sure that we're not storing pressure above a limit that's set, right? So we have that 120 psi limit. This pressure relief valve will vent any air if we start storing air above 125 psi. So there's a little bit of wiggle room. That 120, 125 room is when I said approximate earlier. As long as it's anywhere within that little bit of a range, we're okay. But if for some reason it's storing too high, if something else breaks, I'll talk about the system of how we keep it to that level. If something messes up, this will release air and keep us below 125 psi at all times. This is checked during our robot inspection. So at the beginning of every event, before our robot is deemed legal to actually play matches, we go through robot inspection. There's a volunteer, there's an inspection checklist. They will go through every little item on this checklist, and part of that system is a check of our pneumatics components and how everything's working. Do we have all the right pieces? All of that. Is it going to be safe to operate on the field? And so this is one of those parts that's checked. So this just screws in to a fitting that's connected to the compressor. There's basically a spring in here that's set to the right amount of force, and when air pushes up on that spring, any air pressure below 125 won't be able to move the spring. But if you get air above 125, it moves the spring up, and air is able to vent out of all of these holes, causing the pressure to go down because we're releasing all of that air into the atmosphere. Okay. Pneumatic control module. So this is where we start connecting our pneumatic system to our electrical system that allows us to control it, right? So we talked before, we have this RoboRio, which is the controller for the whole robot, and that's the thing we actually program. And so that device has to be able to talk to our pneumatic system to be able to tell it, okay, when does our compressor turn on and off? When do we want to move the cylinders in and out? And so this is the go-between between the RoboRio and the rest of the pneumatic system, and it's called the Pneumatics Control Module. It gets its power from the PDP, the power distribution panel. So we have power inputs right here. These black and red marked connectors here are a power input. It's connected over the CAN bus, which is these green and yellow connectors here. And so this is how it actually connects to the RoboRio. So the RoboRio can talk to it and tell it what to do. The PCM, the pneumatic control module, can also tell the RoboRio some things. It can tell it like status, what it's doing, all that sort of thing. They can talk back and forth. The most important thing the pneumatic control module does, though, is it's the controller for all the pneumatics, like its name says. So it has a connection for the compressor. So this is what actually turns the compressor on and off and gives the motor inside the compressor electricity so that it can start spinning and compressing air for us. So this connections right here on this side are where the compressor connect. And then each of these connections here are where we're able to connect solenoids, which we'll talk about what solenoids are. But solenoids are how we individually control any of the pneumatic functions of the robot. So that's where we were able to connect them all here. And then this module is able to say, okay, something's on or off, and we can direct the flow of air, which is what we'll talk about in just a second. In 2022, so this module here is what's been on all of our robots for quite a long time. And so any of the robots we see in our lab, any of them who have pneumatics, will all have this module. For our next season, so starting in January, we'll have the option of using this new device called the Pneumatics Hub. Largely, they're going to do very similar things. They're made by two different companies, so there's a few features that are different. But for the most part, they're going to do pretty close to identical things. So the Pneumatics Hub has power input just like the PCM. It has CAN connections that can talk to the RoboRio just like the PCM. It has a place for the compressor to connect, and then it has places for all the solenoids to be driven to, so we can control the direction of airflow. Both the PCM and the Pneumatics Hub have places for a pressure switch, which we'll talk about what a pressure switch is in a slide or two. And then this one is a little bit more interesting, and one of the kind of nice features of the Pneumatics Hub and what we're getting like some of this update for is it actually has a USB-C port right here, so we can connect this directly to a laptop. So instead of having to have the robot and the RoboRio and everything connected and trying to use that if we need to test something with the pneumatics, we can instead just plug this directly in with a USB cable, plug it into a laptop, and then we can control things like the compressor and all these outputs directly from the laptop software instead of needing the robot radio. So if we're testing things, or if we're experimenting, we wouldn't actually use this in a match. That would all be controlled by the RoboRio. But when we're designing things at home, when we're trying to figure out how the robot's going to work, this feature might become very handy. Okay, the pressure switch. So this is where we were just mentioning one of the inputs that the PCM and the Pneumatics Hub both have. And the pressure switch is how we actually know when to start and stop the compressor. So it connects to the PCM. It signals the PCM to turn the compressor off somewhere before it reaches 120 psi, or somewhere right around there. Normally anywhere between 115 and 120 psi is about average, but that few psi doesn't really make a big difference most of the time on any of the robot systems. And then it's also monitoring the pressure once it tells it to turn off. It's monitoring the pressure, and once the compressor or once the air gets to below about 100 or below about 95 psi, so that means we've used some of our air. If we stored air up to 120, we start telling a few different systems to move in and out, and we consume some of that air. We're using air pressure at that point. And once that compressed air has been used, eventually our gauges will start going down and we'll read somewhere closer to like 95 psi. And at that point, this pressure switch will tell the PCM or the Pneumatics Hub to turn back on. So it's connected with these wires here to these ports down here on the PCM. It's connected over here on the Pneumatics Hub in 2022. And so it does that same thing of just really giving us a nice, easy way to know when the compressor should be on and when the compressor should be off. We wouldn't want it to turn on and off like at a single PSI limit, right? If we knew our limit was 120, in theory, you could build a device where it turns the compressor off when it's above 120 and it turns the compressor on when it's below 120. The problem with that is as soon as the compressor turned off at 120, as soon as you moved any, as soon as we used pneumatics at all, the compressor would immediately kick on for a little bit. It would add back that like 1 or 2 psi, and then it would turn off. So you'd be cycling on and off the compressor really, really fast all the time, and that's just not good for almost any motor, especially something like the compressor to be doing that. It would eventually get really hot, it would overheat, and we just don't want that. So we give it that little bit of leeway here to prevent that on and off state from the compressor, because it's totally fine if we're only storing at 95 psi, because remember our regulator means that we can only use pressure at 60 psi. So really, as long as our storage side is above 60, none of our robot actions are going to tell the difference about what's happening on the storage side. All we worry about is do we have 60 psi or not, if that's what we're using on the usable robot side. Okay, so let's get into what we actually do all this for. So all of that is just kind of the setup and is needed to be able to use pneumatics at all, but they don't actually move or do anything yet, right? If you just had that part of the system, you could store a bunch of air, but you couldn't actually use it to accomplish any of our tasks. We couldn't score points with it. We couldn't move parts of the robot. We couldn't do anything. So to be able to actually do stuff and to use it inside of our mechanisms, we need pneumatic cylinders for that. So the pneumatic cylinder is the part that actually moves when we put air in one side or out the other. So pneumatic cylinders provide motion for our robots. Air released into one side of the piston will will move the piston in one way. So this inner part is the piston. So this rod bit and the part down here that kind of generates a seal. So that's the piston. The entire thing is the pneumatic cylinder. And so just by the animations, we can see, right, when we push air in one side, we get the cylinder moving one way. When we push air in the other side, the cylinder moves the other way. What happens with the air that we're not using is that it goes to exhaust. So when we push air in this side, any air that's stored here is going to be vented out of our system, and that's why we talk about using air, because anytime we move a cylinder, some of that air ends up going away. We're just letting it go to atmosphere. Normally, it sometimes get asked is why couldn't we like keep that air around? Couldn't we like store it back into the system again? And the problem with that is we need the cylinder to actually move, right? So if we're putting 60 psi of pressure on this side, we have 60 psi air moving into here and trying to expand and fill this volume. If you also have 60 psi air stored over on this opposite side, nothing will move because you don't have a difference in pressure. And so that's what pneumatics really are. That's how you get motion out of pneumatics, is you have some part that wants to be at a higher pressure, and you want some part that needs to be at a lower pressure, so that the higher pressure can move the cylinder and gain volume. If you had them both at 60 psi, nothing would move at all. So you can't just keep that air. You have to let it go to atmosphere so you can actually have movement. Yeah, so up in the right corner, this is what the pneumatic cylinders look like in real life. This is a smaller one. This is probably a 3/4 diameter or so, and 3 inches maybe. So this rod here probably moves 3 inches in and out. That's my guess. It might be 4. It's hard to tell scale sometimes. So when we put air in this backside, the cylinder rod will move forward. And then when we put air in this front side, the cylinder rod will move backwards. Because you have the bit at the bottom that's basically taking the air and allowing it to move forward and backwards. Okay, so now that we know what a cylinder works, we have to be able to actually control air and tell it to go to either side of the cylinder. Because if we can't actually control it, then we might only have, at the start of the match, the cylinder might be pressurized to one way or the other. It could be out, it could be in, and it would just stay there. And rarely is that helpful. Most of the time, we want to use the pneumatics to be able to like fold something out of our robot. Maybe we're going to use it to push our intake out of our robot so we can collect balls off the floor. Maybe we're going to use it to move some flaps in our robot. Some teams use them even to climb. You can like extend a cylinder really high up with like a hook on it, and then you push air back in the other way and you can lift your whole robot up. Normally, our general rule of thumb is really big cylinders are normally not worth it, mostly because they use a ton of air. So most of the time we're going to try to use relatively small air cylinders, so we use less air. We can fire them over and over again in matches. They're also lighter because they're smaller, and you can normally your overall robot design works better normally with smaller cylinders than really big ones, but they do get used, and you will see teams use them. So back to the point. Solenoids are what do the actual control of the air. So this is where our electrical system and our air system meet for basically the only time, right? So other than us powering the compressor, solenoids are how we actually use and direct that airflow. They connect to the PCM, or in 2022, the Pneumatics Hub. You can connect multiple cylinders to a single solenoid. So a lot of times for mechanisms, we might have 2 cylinders on like either side of our robot, maybe left and right, and they're moving both sides of the intake up and down. You only need 1 solenoid if those cylinders are always going to move in tandem together. If they're always going to be together, you don't need to have a solenoid for each cylinder, because you would never want to only fire one and not the other, because it might like twist something if only like one side of your intake goes down, or one side of your climber goes down, or whatever it is. You don't want any of that twist. So it's okay to have multiple cylinders connected to a single solenoid. The inverse is not true. You're not allowed to have multiple solenoids connected to a single cylinder, and that's for safety reasons. You might be able to put too much air into the cylinder too quickly. You can basically hurt things if you do that. So it's a safety reason why we don't allow that to happen. These are basically what the solenoids that we use look like. So these top outputs here, these top holes, go out to the cylinder. So these top holes would be up here. These bottom holes, this middle one is where air comes in. And then these outer two are where air goes out when we're exhausting the system. So we have a cutaway here that shows exactly what this kind of looks like inside of here. It's not super important to know exactly how this works. Again, we're never going to build any of these. These are all parts that we purchase. But it is useful to not have some idea of what's going on inside of it. So as we're building everything, you have an idea of what these little solenoids do for us. So air comes in through this part labeled P, and then depending on where this valve is, we either have air going out of A, or when it shifts over, so when we would like put electricity to the solenoid, this whole black rod with all of these little discs on it would slide back to the left. And then instead of the air from P going to A, the air from P would go to B. And once the air from P is going to B, the air that was in A, the stuff that we already put in the cylinder, is going to go down from A and out of R. So it's just going to be released, what we call vented to atmosphere. So in this current setup, P is going to A, and then any of the air that's stored in the B side of the cylinder would be exhausting out of the S port down here. So that's all the solenoid really does, is it just moves this little bar back and forth, not very far at all. I think it's somewhere like 1/4 of an inch that's shifting back and forth. So it's a pretty small movement, but that movement's all we need to allow us to shift the direction of the air. And that's normally done with an electromagnet, actually. So when you apply electricity, there's a magnet inside of here that pulls the rod one way. When you don't apply electricity, there's a spring that pushes the rod back, is what normally happens there. Okay, so we've already mentioned this a little bit, but just so everyone has a full diagram or like full understanding of what we mean here with this high versus low side. So the high side of the pneumatics is also the storage side. So this is where we're allowed to have 120 psi air. So the compressor is allowed to store all that air in all of our storage tanks. And so that's all allowed to be up at 120 psi. So this gauge right here before the regulator is what's reading somewhere around 120 psi, anywhere below 125 psi. And then after the regulator, we have the entire low side of our pneumatic system. So this first gauge should never read more than 60 psi. And so that's the amount of air that we're allowed to send to our solenoids, and the amount of air we're actually able to use inside of our cylinders. There are also times where it's beneficial to have even lower pressures. So if we don't want one of the cylinders to move with as much force, because the amount of force the cylinder moves with is directly proportional to how much pressure it is, right? We talk about this pounds per square inch. So if this little cylinder right here, if this like the part of it that's a circle on the back here, if this was exactly 1 square inch, that would mean that when the air comes in here at 60 psi, this would move out with 60 pounds of force. So if we lowered that pressure, we could have it move out with less force. And so maybe there's some mechanism we need to build that needs less force. That also means we're using less air. So if you use a lower amount of pressure, you're using less amount of stored air every time you need to move the cylinder, which can be useful. It means we can have more air throughout the entire match. So there may be times where we need to have a lower PSI here. So there's times where we may just have the main regulator set lower than 60 PSI. You're also allowed to have multiple regulators. So after this main one, so if this main one is setting the system to 60 PSI, somewhere else, if we had another branch, if we had some more tubing, we could have another regulator that then lowers from 60 PSI down to 40 PSI or 30 PSI or whatever pressure we need that's lower before another solenoid and a different cylinder in our robot if we needed to have a lower PSI. So like I said, a lot of times we'll do that to save air, because the more air we can save, the less time the compressor has to be on, and just the less air in our whole system that we're using. Okay, so back to this kind of real life picture. So this was the Spectrum setup on our 2018 robot. So now we can kind of see a little bit more about what all these components are. So all of these components are solenoids. So we had 1, 2, 3, 4, 5, 6 solenoids here. We weren't actually using all of these. So you can see some of them have hoses coming out. Like here we have this white hose with this red tape around it. We'll use color-coded tape to identify where each of the hoses go, so we can identify each end of a hose to know which way they go. So these first two and these back two have hoses coming out. These middle two have these little black stoppers in them. So that means we weren't actually using these solenoids. So they're mounted on the robot, they're wired in, and if for some reason throughout the year, if we needed to add a pneumatic device for some reason, we could just unplug these stoppers and unplug the plugs, and then we could plug in hoses and connect it and just add it to our program that's on the RoboRio to then set when we wanted those open and closed and what we wanted them to be used for. The PCM is here against this like sidewall, and there's a bunch of wires running from the PCM to all of these solenoids, so they're all connected, so the PCM can control each one of these 6 solenoids. The compressor is right here, and this is that little output, and so mounted to the compressor, we have that pressure relief valve, which is the gold thing right here, and our pressure switch. So then the compressor and the pressure switch are also mounted to the PCM. Or connected to the PCM, sorry, not mounted. That allows the PCM to control it, letting it turn the compressor on and off whenever the pressure switch tells it it's ready to do so. And then this output tube here is what's going to go up to all of our storage tanks, so we can store all the air. And then somewhere else on the robot, I don't entirely remember where it was. I think it's right on this backside. It comes from the storage tanks to our gauge, regulator, and gauge, and that feeds back into our solenoids right here, which is all on the low side. So this is all high side, and this has that 120 psi coming from the compressor, but then the hose running down into this silver block right here, which is called a manifold, that's going to be that low side air ready for the solenoids to direct it to the different cylinders on the actual robot. Not all solenoids are connected to manifolds like this. This is just like a space-saving thing, so we don't have to. We can save a bunch of tubes. So this just allows us to put air into all 6 solenoids just by mounting them to this block. If we didn't do that, we'd have to have hoses running to each solenoid and little like T or Y connectors in the hose. And you can do it. It just gets a little bit. It takes up more space, sometimes more weight. Just kind of depends on what we're doing for each robot. Okay, so that pretty much sums up the most everything you need to know about pneumatics for the beginning. So this will help us when we start looking at how we program the FRC robots, because we'll be able to have a better understanding of what it means to for what they're actually doing, so we can program a little bit easier. And then later on, we'll have versions of this for the mechanical side, because we'll talk about how we actually design to use these pneumatic components. So we have to be able to figure out how do we actually mount these to part of the robot so it can actually move in and out, and that sort of thing, which is on the mechanical side, to be actually use these to move our intakes, to move arms, to move whatever we're trying to move with pneumatics at that point. In this presentation, what we'll have, there's a bunch more more resources and references if you want to learn more. There's quite a bit of it. This guide right here, A Bunch of Hot Air, is actually really good about some more of the basic math on how some of the pressures work and how pneumatic components work. But really, the takeaway is that compressor compresses air, adds it up, stores it in the air tank. It goes through the regulator to get to our low side, and then all of these solenoids are there to control when air is put into either side of the cylinder, so we can actually use it on the robot. And that's the biggest takeaway to remember. And we will go through. We have to some more as we build electrical robots and as we're working on them. You'll get to see how all the components exactly work and feel them and everything else. But it's really good to have a good basic understanding of all the theory and why all these parts are here to build out the whole system.